In this video, let us talk about pandas arithmetic operations. For that, initially I will import the libraries pandas as pd and numpy as np. Let me write the series with s1 and s2. Let me put it in one line. Now, if I would like to execute s1 and s2, simply I can just type here s1 and s2. So here I would like to add s1 plus s2. Now we have got something for s1 plus s2. See, here we have nan because there are some missing values in the series s1 as well as in the series s2. Things that are common in series s1 and s2 are only added and the remaining will be represented as nan here. That is the meaning. Now let's look at data frame. Now again I would like to bring it on the same line. We have data frame df1 which is having numpy.arrange. That means we have values from 0 to 5 and with 2 rows and 3 columns, and we are giving the columns as A, B and C and the rows as Tim and Tom. Similarly for the other data frame 2 also. Now let us execute df1. Also let us try for df2. Now this time again I would like to add here df1 and df2. Let's see what we have got here. Here it is the same thing like we have observed in our series. The one which are common between df1 and df2 will be executed here. We have only common Tim of A, Tim of C, Tom of A and Tom of C, and the remaining we are getting nan because it is not common in both df1 and df2. Suppose if you would like to fill some value that is common in both df1 and df2, in that case we would like to use the method called add df2. If you just do shift and tab, you'll get here fill value. You can just copy it from here. Fill value by default it is none, but here I would like to give the value called 0. So most of my nans will become 0 here. The only nan we will get because there will be something which doesn't have the value in df1, also it is not there even in df2, then only we'll get nan, otherwise we'll get 0. So here we go. Here we have got only one nan because we don't have kate of b here in the df2, also in df1. That is why we are getting nan. Now this time I would like to do the division. 1 divides by df1. So the entire matrix here df1, we got 1 divides by 0 is infinity, 1 divides by 1 is 1. So it will be applied to the entire matrix. Let's look at the multiplication. Now we can directly multiply with 3. So the entire matrix will be multiplied with 3 here. 3 into 0, 3, 3 into 1, 3, 3 to the 6, so on. This is about multiplication. So we can also do multiplication in another way. Simply just type df1 dot and then just mu tab, you'll get mul, and then simply use 3 or 4, let us say 3 only, so we get the same kind of output. This is also another way we can do. Let me just go for data frame D2. Let's see what is there in the DF2. This time I would like to retrieve the location of index 1 in data frame 2. For that I would like to assign a variable s. Let's say we have df2 data frame, and if I would like to locate, I can just use iloc and square brackets open. So I would like to retrieve the kate 345. So for that I can just use 1 here. So when I execute s, I just got kate 345, which is ACD. Now from here I can also do subtracting with df2 and minus s. So here we can see that this can be subtracted from the data frame and the series. So 0 minus 3 we have got minus 3, 1 minus 4 we have got minus 3, 2 minus 5 we have got minus 3, and so on. 3 minus 3 again 0, 4 minus 4 again 0, 5 minus 5 again 0, and it is also going to do the same thing for the other row, similar to like our matrix subtraction. Let us take a data frame df here. Let's execute df. Now here in our data frame we have got some negative values. So for this we will use absolute function with the help of numpy array. Absolute, and then I'll just put df in this enclosed brackets. So all that with negative sign have gone from my screen, right? I can just use a sign again, it is equal to df. Now df will show only all positive values. Now here, if I would like to use a functions in this, so this time I'll just assign a variable called f, and I will use an anonymous function called lambda. Now here I will just assign the value of x as x dot max minus x dot min, so that I can perform this operation in this data frame. Now this time I will just apply. For this I will do df dot, just simply tab, there will be an apply function, okay, app, then apply. Okay, now here I would like to put this f inside these brackets. So here I have got the values between, not between, here I have got the values for x, which is saying that minimum minus maximum. So if we can check that with our calculator, let's do that with our calculator. Okay, so here in a we have 0.81 is a maximum, okay, and 0.196 is okay. So what it is taking here, it is taking it is giving a row wise operation here, it is taking a row wise operation. Now if we would like to perform this with column wise operation, in that case I would just simply do copy this and just use axis. Let me just do the tab here so that I'll, okay, by default axis is equal to 0. That means when axis is equal to 0 it will perform row wise operation. When we are putting axis is equal to 1, then it will perform a column wise operation. Now we can also check whether it is doing column wise operation or not. Now here 0.816 is the maximum in the column, and again we have zero point 0.8, sorry, 1.02 is the maximum and minimum is 0.816, so which will be 0.024, which is correct. right? This way we need to apply this. Similarly, let us use another function def. Let's say that we would like to square all these values from the data frame. Then I will just define a function fx, okay, and I would say I would like to return it with x to the power of, I would like to just square of those values, okay, x to the power of 2. Now here I would like to use the same method called apply, okay, and put f inside this so that I will get the data frame with these values to the power of 2. Let's see whether it is coming correct or not. 0.81 um, 0.816059, it is square, right? So we have got 0.66, that's correct. So all these values from the data frame are going to give the power of 2. So this is it in this video. I'll see you in the next one.